In this lesson, you'll learn more about the unit circle. We're going to work through 3 different kinds of questions that involve the unit circle, and this is the first one. The measure of theta is 4 pi over 3 radians. Find the 6 trig functions of theta. On our graph over here, we have the unit circle, and we have the initial side of theta on the positive x-axis and the terminal side over here in the third quadrant. So theta is this angle. We need to identify the point where the terminal side of theta and the unit circle meet. So to find that point, we need to know how far from the origin we came over on the x-axis and how far we dropped down on the y-axis. Now let's start by finding the measure of this angle here. If the full theta equals 4 pi over 3, we can subtract pi radians, and that's going to give us pi over 3 radians. And I'll label this angle beta, so I'm going to put up here beta equals pi over 3, and this is the angle beta we're referring to. Now you need to think back to your geometry and your special right triangles. So here's our right triangle, and beta is here with a measure of pi over 3 radians. Pi over 3 radians is equivalent to 60 degrees, so this is a 30, 60, 90 degree triangle. The side length ratios of a 30, 60, 90 are going to be the square root of 3, 1, and 2. Since we're on the unit circle in our graph over here, we want our hypotenuse to have a measure of 1 unit. And we can accomplish this by dividing all sides by 2 to get a hypotenuse of length 1. One leg will equal the square root of 3 over 2 units, and the other leg will be 1/2. That means from the origin, we've come back 1/2 unit and dropped down negative square root of 3 over 2 units. So the point that we were looking for is negative 1/2, comma, negative square root of 3 over 2. Now once we have the point on the unit circle, we're able to find the 6 trig functions easily. Sine of theta is always our y value, so this will be negative square root of 3 over 2, and cosine is always our x value, which is negative 1/2. Tangent is the ratio of sine over cosine, so to get tangent, we'll do a little simplifying down here. We'll have negative square root of 3 over 2 divided by negative 1/2, and that's going to simplify to negative square root of 3 over 2 times negative 2, which gives us a positive square root of 3. So tangent theta is the square root of 3. And then from here, to get cosecant theta, we just take the reciprocal of sine, which gives us negative 2 over the square root of 3. And once we rationalize the denominator, will give us negative 2 square roots of 3 over 3. For secant theta, we'll take the reciprocal of cosine theta, so that'll give us a negative 2. And then for tangent theta, we'll take the reciprocal of the square root of 3, which is 1 over the square root of 3, and we'll go ahead and rationalize this denominator to get square root of 3 over 3. And this gives us the 6 trig functions of 4 pi over 3 radians. Now let's take a look at the next problem. So this question tells us that this point is on the unit circle, and the question is, what is the radian measure of the angle passing through this point? So we're looking for the measure of this angle here, and we'll call this angle theta. To find the exact measure of this angle, we need to see if possibly we have one of our special right triangles here. We're coming from the origin, the square root of 3 over 2 units, and then we're dropping down 1/2 unit. So let's take a look at this triangle away from the circle for a minute. The triangle looks something like this. We have the right angle here, and right now we're looking at this small angle. Now this angle isn't theta, it's the reference angle for theta. We have the horizontal side length of square root of 3 over 2 units, and we have the vertical side length of 1/2. We also know that the hypotenuse of this triangle, because this angle is on the unit circle, will be 1 unit long. To check and see if we have a special right triangle, we could multiply all of these sides by 2 and then take a look at the side lengths. When we multiply the hypotenuse by 2, we get 2 for our side length measure. When we multiply this short leg 1/2 by 2, we get a measure of 1. And when we multiply the square root of 3 over 2 by 2, we simply get the square root of 3. And this does turn out to be one of our special right triangles. This is a 30, 60, 90 degree triangle, and the angle here that is across from our shortest side is our 30 degree angle. 30 degrees written in radians is going to be pi over 6 radians. So if we come back over here, we now know that this angle, the small angle inside, is going to be pi over 6 radians. Since we're looking for the angle on the outside, we need to take the full revolution of 2 pi radians and subtract pi over 6 radians. And that'll give us an angle measure of 11 pi over 6 radians. So the measure of the angle that's passing through this point, the square root of 3 over 2, comma negative 1/2, is 11 pi over 6 radians. Now let's take a look at one more problem. Find the 6 trigonometric values for an angle that measures 19 pi over 4 radians. Since there are multiple revolutions of a circle that make up 19 pi over 4 radians, let's scale this back until we can see what's happening with less than one revolution. So in other words, let's take this 19 pi over 4 radians and subtract 8 pi over 4 radians. That is 2 pi radians, which is a revolution, and see what we get with that. That's going to give us 11 pi over 4 radians, which is still more than a complete revolution. So let's do it again. Let's take away another 8 pi over 4 radians, and that's going to give us 11 minus 8 is 3 pi over 4 radians. Now let's make a drawing to make sure that we understand what we just did. We have our x and y axes, and we started with the initial side of our angle on the positive x-axis. We made one revolution, which was our 8 pi over 4 radians. We made a second revolution, which was another 8 pi over 4 radians. And then we were going another 3 pi over 4 radians, which puts the terminal side of our angle in quadrant 2. Notice that 19 pi over 4 radians and 3 pi over 4 radians are coterminal angles. And 3 pi over 4 radians is going to have the same trigonometric values as 19 pi over 4 radians. The point that corresponds on the unit circle to 3 pi over 4 radians is negative square root of 2 over 2, comma square root of 2 over 2. So this gives us the sine of 19 pi over 4 radians will equal the square root of 2 over 2. Cosine of 19 pi over 4 radians is going to equal the negative square root of 2 over 2. And the tangent of 19 pi over 4 radians will give us the square root of 2 over 2 divided by the negative square root of 2 over 2, or just negative 1. The cosecant of 19 pi over 4 radians will give us 2 over the square root of 2, or the square root of 2 once we rationalize the denominator. The secant of 19 pi over 4 radians is going to give us the negative square root of 2, and cotangent of 19 pi over 4 radians is just going to give us another negative 1. So here we have the 6 trigonometric values for the angle measuring 19 pi over 4 radians. And now you know a bit more about the unit circle. See you next time.